In this session, we're going to focus on the effect of resistance on different components in a circuit. What I have with me is 3 LEDs, which are the same color. And we have 3 sets of resistors. We've got this set, which is 10 kilo ohm resistors, this one, which is 220 ohm resistors, and this is 2.2 kilo ohm resistors. What we're going to do is connect these LEDs using these resistors to a Raspberry Pi Pico, and then we're going to light them up to see the effect on the intensity of the LED connected to different resistors. To get started, I'm going to look at this pin out diagram of our Raspberry Pi Pico, and I'm going to connect our LEDs strategically so that we can see all 3 LEDs and we're able to connect different components. So I'll connect to the pins which are on the outside for convenience, starting with this one here, which is GPIO 0. So I'll put the long leg in GPIO 0, and the short leg is going to an empty row. And then I'll take another one and connect it on GP15, which is that bottom one there. So the long leg goes in there, and the short leg goes into another row with nothing in it. And then I'll connect our third LED in GP16, which is that one there. So long leg goes into that same row, and short leg goes into a row with nothing in it. So we've connected our 3 LEDs, and then I'm going to use a jumper cable, male-to-male jumper cable, to connect ground to a common rail, to the blue rail there. So I'll take the third pin there and plug that in there and connect it to that blue rail there. So this blue rail is now our ground, which we can connect to. So I will start with GP0, and I'll put the least resistance. The least resistance of these is 220 ohms. So I'll take a resistor from here. I'll bend the legs so that the resistor can go into our breadboard. And one of the legs is going in the same line as the short leg of this LED, and the other leg is going into that blue rail there. Make sure that the legs of the resistor do not touch the legs of the LED, otherwise you'll have a short circuit. Then let's take the next least resistance, which is the 2.2 kilo ohm. And let's bend the legs and connect it to GP15. So one leg is going in the same row as the short leg, and the other leg is going into the ground. And then we'll take the highest resistance, which is our 10 kilo ohm. I'll just pull that out. And with this one, we would like one leg to go in the same line as that leg, and the other leg to go to ground. But because this ground here, that blue line, is far away from there, our legs of our resistors are not going to be able to come into that row and come there. So we'll look for an alternative ground, and the next ground is the third pin from there. So that's 1, 2, that pin there is our next ground, which we are going to connect to. So I'll just bend the legs of our resistor and put one leg in line with that and the other leg in line with that pin there. So you can see we've got 3 LEDs and 3 resistors of different resistance. And now what we're going to do is connect our Pico to the computer. Now that we've connected our Pico to the computer, I'm going to open Thorny. Having opened Thorny, the next thing is to write the code to switch on the lights. And we're going to import the machine function from machine, import pin. And then we're going to name the 3 lights. And just for short, we'll say G1, which is the one connected to pin 0. So we'll say pin 0, comma, pin out. And remember, G1 it has a 220 ohm resistor. Then we'll say G2 is equal to pin. And if you remember from our pin out, we connected it on GP15. So we'll say 15, comma, pin out. And then G3, which is the last green light, is pin, brackets, GP16, and it's a pin out again. Let's now switch them on. So we'll say G1 is value 1 to switch it on, G2 dot value 1 to switch it on, and G3 dot value 1 to switch it on. That's our code written, and let's save that code. We'll save it to the computer once again, to the desktop, and we will say, call it resistance, and save that. So let's go ahead and run that code, and you'll see that all 3 lights are on. You may notice that this light here is on, but it's very faint. This light is on, but it's not as bright as this one here. Let me just go through and make this a while loop. So we'll just stop that, and let's create a while loop and put this into a while loop. While true, we'll switch them on one by one, and we'll give them 1 second or 2 seconds. But because we're now using a sleep function, we need to import that from time, import sleep, so that we can use that sleep function. And then after 2 seconds, we'll switch on the next one and have it sleep another 2 seconds. And then after that 2 seconds, switch on the next one and have them all on for 10 seconds. And then after 10 seconds, let's switch them all off again. So G1 dot value 0, G2 dot value 0, and G3 dot value 0. And then let's just put a sleep function, 3 seconds sleep, so that it loops like that. I'm going to click save, and then let us initialize all of the lights to be off, because you can see the lights are on. If I run it right now, you will not see what's actually happening. So let's initialize all of the lights to be off. So G1 dot value 0, G2 dot value 0, and G3 dot value 0. Let's make sure that they're off for at least 2 seconds before we actually see them coming on. Sleep 2. There we go. Let's save that. And now I'm going to run the program. They're all off, and then after 2 seconds, the first one switches on, next one, and the third one. And there you have it. So the higher the resistance, the less light that your LED produces. But you need to make sure that you're connecting your LED to a resistor which gives it protection. If you use smaller resistances than 100 ohm, you might find that your LEDs blow out.